This video is presented to you by www.testprepadda.com. Dear students, in the previous lecture of kinematics, I talked about equations of motion. I talked about straight line motion with constant acceleration. In this session, I will talk about applications of equations of motion. Application to find distance, number one. Number two, to understand the motion of particle in a particular second. Now, if you look at these three equations of motion, which we have derived in previous sessions. Number one, V is equal to U plus AT, S is equal to UT plus half AT square, and the third one, V square is equal to U square plus 2AS. Here U is initial velocity, V is velocity at time t, A is constant acceleration, T is time taken, and S is displacement of the particle. Now the point is, here S is displacement of the particle. But if the question says find distance, then what to do? For example, read this question. Here question says a particle having a velocity of 2 meters per second is accelerated with 1.6 meters per second square for 10 seconds in the direction of velocity. Find the distance traveled during this time. Now question talks about distance, but in our equation of motion we write the displacement. Okay, so now I will tell you when can we take this displacement as distance, or how to use equations of motion to find distance. There are three cases. First, I'll talk about case 1. In the case 1, if the initial velocity is given as 0 and particle is accelerated with a constant acceleration A. Constant acceleration A. Then we can take that displacement equal to distance. And if I use S is equal to UT plus half AT square, since U is 0, the remaining part will be half AT square. Got the idea? So this is the case where the displacement can be taken as the distance. Now we'll talk about case 2. If the initial velocity u and acceleration acceleration A, they have same direction. Same direction. The particle is moving in this direction. Acceleration is also in this direction. Then we can take that displacement ut plus half at square, same as the distance. Got the idea? So this case, in this second case, the initial velocity and acceleration both have same direction. Okay. Now I'll talk about case 3. Here, the initial velocity u and acceleration a, they have opposite directions. And question says, find distance traveled by the particle in time t seconds. Got the idea? So, particle is moving in this direction and acceleration is in this direction. So what will happen? Initially the motion is retarded because A is in the opposite direction. So the velocity of the particle will keep on decreasing and finally it will become 0. So here you can say velocity becomes 0. Now get this time. Get this time when the velocity of the particle becomes 0. So if I consider this time as t1, to get this I'll use equation of motion. V is equal to u minus at. I have written here minus at because a is in the opposite direction of u. So 0 is equal to u minus at. So t will become u by a. So t1 I'll write here t1. t1 is equal to u by a. So the important point is, whenever you get this type of question where initial velocity and acceleration are in opposite direction, get this time when the velocity of the particle becomes 0. If this time t, if this time t is less than or equal to t1, then the displacement will be equal to distance traveled. That means you will write ut minus half at square. Got the idea? So basically the question talks about this motion only. Okay, so here the motion is retarded and the displacement or distance can be found using formula ut minus half at square. But there is another possibility. If this time t is greater than this t1, given time t is greater than t1, this means the particle starting from velocity u in the direction opposite to acceleration. So here the velocity becomes 0. Since the time taken in this motion is t1 and this given t is greater than t1, means now the particle will move in the direction of acceleration. So it will be like this. Okay, now after this you have to find d2, let us say, and here let us say this as d1. So first you get d1. D1 will be what? D1 will be ut minus half at square. So t you will write as t1 here because time taken here is t1. And t1 we have already calculated as u by a. Got the idea? Now t2. T2 you will find again, since for this motion the initial velocity will become 0, I'll write this as half a t square. Now this time will be how much? We have already taken t1. The particle has already traveled for t1 time. So remaining time will be how much? T minus t1. So t minus t1 I'll write here square. So this is another distance traveled by the particle. So what will be the total distance traveled by the particle? Total distance traveled by the particle will be d1 plus d2. Got the idea? So these are the three cases where we convert our displacement into distance. But if the question says find displacement only, then simply use for displacement, simply use S is equal to ut plus half at square, and this u will be taken as positive and this a will be taken as negative, and this t is total time of traveling. Got the point? Now I will take the question with which I started this session. Here the question says, a particle having a velocity of 2 meter per second is accelerated with 1.6 meter per second square for 10 seconds in the direction of velocity. Find the distance traveled during this time. Now this question says the velocity, initial velocity and acceleration both are in the same direction. So this question actually belongs to case 2 which we discussed in this session. So here we can simply say that displacement is equal to, magnitude of the displacement is equal to the distance traveled during the given time. So I'll use d is equal to ut plus half at square. U is given as 2, time of travel is 10 plus half, A is given as 1.6 and time of travel is 10. So I'll write this. Now if you solve, it will be 20 plus here you'll get 80 and total this way comes as 100 meter. Okay, now I'll take another question here. Here the question says, a car starts from rest and travels with a constant acceleration of 2 meter per second square for 30 seconds. And then brake is applied to stop the car. The car comes to the rest in 60 seconds. Find the total distance traveled by the car. Now again we have to find distance using displacement equation of motion. So you can see the initially car is having velocity 0. Now the acceleration is given as 2 meter per second square. So this actually belongs to case 1 which we discussed in this session. So the car will move like this for 30 seconds. So we will get this distance that the car will travel in 30 seconds. So D1 will be written as UT plus half AT square. So this will be half into 2 into 30 square, and finally it comes as 900 meter. Now get the velocity of the car after traveling this d1 distance. That velocity can be found with the help of v is equal to u plus at, and if you substitute values a as 2 and t as 30, you will get 60 meter per second. Now after this, the brake is applied, means the motion will be retarded, and after some time the velocity will become 0. So for this motion, the initial velocity will be taken as 60 meter per second. Got the idea? So first of all, get the deceleration or acceleration which is in the opposite direction now because brake is applied. So use v is equal to u minus a dash t, let us say. Okay, because the question says the car comes to the rest in 60 seconds. So this you will take as 60 seconds, this part. So put all the values here. Velocity final will be taken as 0. Initial will be taken as 60 minus a dash. T will be taken as 60. So a dash comes as 1 meter per second square. Now we use this deceleration to find, let us say, this distance as d2. So d2 will be equal to ut plus minus half at square. U will be written as 60 here, time will be written as 60 seconds, minus half, a will be written as 1, and t again 60. If you solve this, it comes 1800 meter. So what will be the total distance traveled by the car? D1 plus D2. So D will be written as D1 plus D2. D1 we have got as 900, D2 we have got as 1800. So it will come as 2700 meter. Got the idea? Now I'll take another question here to understand the three cases which we have discussed here. Here the question says, a car is given initial velocity of 40 meter per second in the positive x direction, and car is under acceleration of 10 meter per second square in the negative x direction. Find the distance traveled and displacement of the car in 2 seconds. Number 1. Number 2, 6 seconds. Now you can see the acceleration and the initial velocity. They are in the opposite direction. So what will you do here? Get the time t1 when the velocity of the particle becomes 0. Get this time t1. How will you find this time t1? U by A. We have discussed this in case 3, and that comes as 40 upon 10. That means 4 seconds. Now, in the first question, you can see 2 seconds. First part of the question, 2 seconds. So, 2 seconds, that is given time, is less than t1. Means question talks about this motion only. So, d1 can be found, or better you say D can be found using formula ut minus half at square, and substitute the values t as 2 seconds, u as 40, and a as 10, and again t as 2. You will get answer as 60 meter. Now in the second part, you can see here the 6 seconds is actually greater than this t1, 4 seconds. T is greater than t1. So what will you do? First get this total distance traveled when the velocity of the particle becomes 0. Let us say this as d1. d1 will be how much? d1 will be ut minus half at square, and if I substitute 40 into 4, this motion, the car travels how many seconds? 4 seconds. Minus half, a is given how much? 10 into this 4 square. This d1 comes as 80 meter. Now after this velocity 0, the car will travel in the direction of the acceleration. So the car will travel in the direction of acceleration. So I can take initial speed now 0, and the acceleration is already given 10 meter per second square. So if I get d2, it will be half at square. How much time left? Total time of travel is 6 seconds. We have already taken 4, so 2 seconds left. So I'll write half, this as 10, and here I'll write 2 square. So this d2 comes as 20 meter. So the total distance traveled by the car is how much? d1 plus d2, and that is 100 meter. 80 here d1, 20 is d2. So total distance traveled by the car is 100 meter in given 6 seconds. Now in the next lecture, I'll talk about the motion of the particle in a particular second. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.